Hi everyone, in this video we're going to explore two of the most basic yet crucial concepts in Kotlin, Val and Var. Understanding these is absolutely essential for writing clean, safe, and efficient Kotlin code, especially if you're coming from another language like Java. Let's start by looking at how we declare variables in Kotlin. Unlike some other languages, Kotlin gives us a clear choice between a read-only reference and a mutable reference. This distinction helps prevent many common programming errors. First, let's talk about val. You declare a variable using val when its reference should remain constant after it's initialized. Think of val as declaring a read-only reference. Once you assign a value to a val variable, you cannot reassign it to a different value later in your code. As you can see, the moment we try to change my name to Trung after it's been initialized to Ton, Kotlin immediately gives us a compilation error. This is a great safety feature. For those of you familiar with Java, val is very similar to using the final keyword for a variable. It means the reference itself is set once and for all. Now, here's a crucial point for beginners. While a val variable holds a read-only reference, it doesn't mean the object it refers to is entirely immutable. Let me show you an example. Notice here, we declared mutable list using val. This means we cannot reassign mutable list to a new list. However, because mutable list of creates a mutable collection, we can still modify the contents of the list by adding or removing elements. The reference to that specific list object hasn't changed, but the state of the object it points to has. This is a very important distinction to grasp. The val keyword guarantees the reference is constant, but the object itself might still be modifiable if it's designed to be mutable. For val variables, the Kotlin compiler requires them to be initialized when they are created. If you're not initializing your variable immediately, and instead assigning it at a later point, the compiler won't be able to infer the type for the variable. In this case, you need to specify its type explicitly. Next, let's look at var. The var keyword declares a reassignable reference. This means you can assign other values to this variable even after it has been initialized. As you can see, no errors this time. We successfully changed the value of my age. If you're coming from Java, var is simply like a regular, non-final variable. You use var when you know that the variable's value, or the object it refers to, will legitimately change throughout the execution of your code. Let's summarize the core differences between val and var. Val, from value, declares a read-only reference. It can be assigned only once. Var, from variable, declares a mutable reference. It can be reassigned multiple times. To illustrate the behavior with different types of collections, let's consider this table. Val with list of 1, 2, 3, an immutable list. Reference can change, no. Object state can change, no. Val with mutable list of 1, 2, 3, a mutable list. Reference can change, no. Object state can change. Yes, you can add remove elements. Var with list of 1, 2, 3. Reference can change. Yes, you can assign a new list of or mutable list of. Object state can change. No, the current list of is immutable. Var with mutable list of 1, 2, 3. Reference can change, yes. Object state can change, yes. This table really highlights the power and flexibility Kotlin gives you by making the mutability of the reference distinct from the mutability of the object's contents. You might have noticed that in our examples, we didn't explicitly write out the string or int types. For example, we wrote val myname equals ton instead of val myname, string equals ton. This is thanks to Kotlin's powerful feature called type inference. The Kotlin compiler is smart enough to automatically determine the type of a variable from the value you assign to it. This significantly reduces boilerplate code, making your code more concise and readable. However, it's crucial to remember that Kotlin is still a strongly typed language. Even if you omit the type declaration, the variable does have a type, and Kotlin will enforce it. Here, greeting was inferred as a string. Trying to assign an integer to it later results in a type mismatch error. The compiler catches this at development time, which is much better than discovering it as a runtime crash later on. For beginners, a general best practice in Kotlin is to prefer using val over var whenever possible. Why? Because code that relies more on immutable data and read-only references is typically safer, fewer unexpected side effects, especially in concurrent programming, more predictable, easier to reason about and debug, more robust, less prone to certain types of bugs. You should only use var when you genuinely need to reassign a variable's reference or value. This pragmatic approach allows Kotlin to combine ideas from object-oriented and functional programming paradigms, making your code both flexible and safe. Finally, a small but pleasant detail. As you might have noticed throughout our examples, semicolons are optional in Kotlin. You generally don't need to put them at the end of each statement. This further contributes to Kotlin's conciseness and readability. And there you have it, a comprehensive look at val and var in Kotlin. These two keywords are the foundation for managing data in your programs. Practice using them and always ask yourself, does this variable really need to change its reference after initialization? If not, reach for val. In our next video, we'll dive into Kotlin's next component. So, see you guys in the next lecture.